Hello. Hello. Please remain silent for some time.
Dear participants and students, please maintain silence for a few minutes. The conference is going to start.
Students, please remain silent.
Hello.
Dear participants and students, please maintain
Please, students, maintain silence for some times.
A very good morning to one and all present here. Knowledge grows when shared, and today's conference stands as a platform for intellectual exchanges and scholarly discussion. I warmly welcome you all to this one-day national conference. This gathering brings together minds committed to learning, research, and innovation. I take great pleasure in welcoming each one of you to this national academic event. It gives me immense pleasure to extend a warm and cordial welcome to this gathering on this occasion. At this outset, I extend a respectful and heartfelt welcome to our chief guest, Dr. E. Nyanamani, Associate Professor, Department of Chemistry, IIT Roorkee, whose gracious presence adds great values and honor to this occasion. I also extend my heartfelt welcome to our another chief guest, Dr. E. Arivalagan, Associate Professor, Department of Chemistry, NIT Trichy. I extend a warm welcome to Dr. Reverend Father Anthony Sami, SJ, Secretary, AAC, whose guidance and support has been instrumental in organizing this academic event. I also take this opportunity to warmly welcome Reverend Father Anbarsi SJ, Principal, AAC, for his constant encouragement and visionary leadership. I also cordially welcome Dr. S. Rayapan, Vice Principal, for his continuous support and motivation. I also welcome Dr. N. Savita Devi, Head of the Department, whose efforts has been central to the successful organization of this conference. I extend a warm welcome to Dr. M. Deva Prince, Dean of Science, and Dr. A. John Jeevagan, Organizing Secretary, for their academic leadership and encouragement towards research and innovation. A warm welcome to all the distinguished speakers, research scholars, and participants gathered here today.
To seek the blessings of the Almighty for the successful commencement of today's program, we begin with a prayer song. I now invite PG and UG girl students to render the prayer song.
என் சுவாச காற்றே என் வாழ்வினூற்றே இறைவா என் உள்ளம் வருவாய் என் உயிரின் உணவே என் வாழ்வின் வழியே தலைவா நீ உன்னை தருவாய் என் வாழ்வும் என் வளமும் எல்லாமும் நீதானே இறைவா தலைவா அன்பினை பொழிவாய் என் சுவாச காற்றே என் வாழ்வினூற்றே இறைவா என் உள்ளம் வருவாய் என் சொந்தம் யாவும் என் தேவையாவும் நீதானே நீதானே இறைவா என் நெஞ்சில் நேசம் மாறாத பாசம் தருவாயே தருவாயே தலைவா வாழ்நாள் எல்லாம் நீ வேண்டுமே வளர்ந்திட நாளும் வரம் வேண்டுமே வாழ்நாள் எல்லாம் நீ வேண்டுமே வளர்ந்திட நாளும் வரம் வேண்டுமே வாழ்வாய் வழியாய் நிறைந்திட வருவாய் என் சுவாச காற்றே என் வாழ்வினூற்றே இறைவா என் உள்ளம் வருவாய்.
please remain still for Tamil Taiwan.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிதில் தெக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you, friends, for the soulful prayer and Tamil Thai Valtu.
To formally welcome the gathering and the participants of EFC 26, we are honored to invite Dr. N. Savitha Devi, Head of the Department, to deliver the welcome address. She has been a guiding force behind this conference and had continuously inspired academic excellence and research initiative in our department. May I request ma'am to kindly come forward and welcome the gathering.
Respected Reverend Father Secretary, Reverend Father Principal, Dr. Jnanamani, Dr. Arivalagan, my dear colleagues, faculty members from other colleges, researchers, participants, and my beloved students. A very good morning. And a warm welcome to all of you at the inaugural session of the National Conference on Expanding Frontiers in Chemistry, Arul Anandar College. This is the 26th year of our conference. Last year we celebrated Silver Jubilee year of conference. This is the 26th year. I'm really happy for the conference. I wholeheartedly welcome all of you. I welcome Reverend Father Secretary, Dr. Anthony Swami S.J., who has visionary stewardship and unwavering commitment to academic excellence. Your encouragement has been a guiding light to the department. Welcome you, Father. A warm welcome to Reverend Father Principal, Dr. Anbarasa S.J., whose inspirational leadership has fostered innovation and motivated all of us. Welcome you, Father. With immense pride, I'm delighted to welcome Dr. Jnanamani, Associate Professor of Chemistry, IIT Roorkee. Your expertise will spark transformative ideas, motivate young researchers and students to learn, innovate, and shine. Welcome, Dr. Jnanamani. I'm happy and excited to welcome Dr. Arivalagan, Assistant Professor, NIT Trichy, who have come over here to enlighten our students with his research. Welcome, Dr. Arivalagan. I extend a warm welcome to our another resource person, Dr. Svapriya Kribaharan, Professor and Head, Department of Chemistry, Indian Institute of Technology, Gandhinagar. I'm happy to welcome our Vice Principal and Dean Academic to the conference. Welcome you, sirs. With immense pleasure, I'm delighted to welcome our faculty members who always render unwavering support to the department in all activities. Welcome you all. I'm happy to welcome Dr. John Jeevahan, Organizing Secretary of EFC 26. Welcome you, sir. I extend a warm welcome to all our participants and presenters. With all your participation, our conference has become successful. Welcome you all. With utmost happiness, I'm delighted to welcome all my beloved students for this conference. This will really help you to have an idea of chemistry and the research going on. Welcome you all. At this juncture, I want to share a point. The brochure, invitation, and whatever the conference proceedings and all these things were designed by our PG students, second PG students. This is what our management asks us, is it? So our students, they have taken a step ahead to create all these things. I welcome all our MSc students who have supported our conference. Welcome you all. I welcome you all again. Thank you.
Lighting the lamp symbolizes the dispelling of darkness and the aspiring in the knowledge, wisdom, and enlightenment. To invoke the blessings of the Almighty and to mark the auspicious beginning of this one-day national conference, we now proceed with the lighting of the lamp. I respectfully invite our esteemed chief guest, Dr. E. Jnanamani, along with Dr. C. Arivalagan. We respectfully invite our chief guest, Dr. E. Jnanamani. Along with Dr. C. Arivalagan. Reverend Father Secretary. Reverend Father Principal. Our head of the department. To kindly come forward for the lighting of the lamp. May I request the dignitaries to please proceed to the lamp. Thank you, dignitaries. Felicitation is a sincere expression of our gratitude and respect. We now move on to the felicitation ceremony. I invite Reverend Father Secretary for felicital address.
Good morning, friends. Good morning. I would like everyone to be settled. Respected Reverend Father Principal, the guests of honor, Dr. Jnanamani and Dr. Arivalagan, the Dean of Science, the Head of the Department, the Vice Principal, members of the staff from our own college, from other colleges, and my dear student friends from our own college and from other colleges, and also those who are attending online. It is my pleasure to be with you this morning when you are having your national seminar, which is taking place consistently for the past 26th year. It is something remarkable. Anything that has a long history means it is always alive. And any research, it has to be alive all the time, which means we are never satisfied with what we have found. We always go further and further. That is the motto of St. Ignatius, the founder of the Society of Jesus, whose members is managing this college. Because if a man says or a woman says, I am okay, I am satisfied, which means he will not stay in the same place. He is going down. Nobody can be static in this. the development of knowledge is not static. It has to be always dynamic, moving ahead. And the Department of Chemistry is a good example for this. The amount of research that is done by the staff members as well as the students. Because the students are more eager to know what is ahead of them, what has come latest in the scientific world, which will give them an advantage from others. And quite a few, I know from your PG departments, quite a few students are interested in that way. I know now we got 2 of our students are in Trivandrum attending a program there, and quite a few other places, which means the department is really giving importance for research. When you are giving importance to research, automatically your knowledge development of the subject is taking place. Even the people who are disinterested will be pulled to be interested in the subject. And that's what's happening in the Department of Chemistry. And I am very happy that the head of department and all others, it's not just one head of department, all others, the deans, because the department has contributed to the administration of this college 2 people, one vice principal, another one the dean of science, which means the department is fully participating in that progress of the college. Therefore, I'd like to congratulate the department head and all other staff members. My only wish is it becomes soon a research department. Any department which is having such a long history of conducting a program annually without any break, it has to become a research department. When it becomes a research department, automatically the higher amount of number of publications will be there, and the contribution for the scientific will be much more, rather than just 1 or 2 staff members guiding students or 1 or 2 staff members interested in that. Therefore, I would like the department to work towards it so that within the next year it becomes a research department, so that the contribution of the Arul Anandar College in the chemistry, it must be something remarkable in the scientific world. And we have a number of Jesuits interested in the scientific research, quite a few from the very beginning. Because one of the leading scientists were Jesuits in earlier times, both in Loyola College as well as in St. Joseph's College, later in St. Xavier's College. When I was principal there, we got 3 people, world-recognized scientists. Even today, we have 2 to 3 people who are within the 1,000 world-known scientists in St. Xavier's, and one of them is chemistry. Therefore, chemistry is something more developing in recent years. The participants, I would like you to concentrate, to pay attention to this, what has been the latest development in this, and try your best to cope with that, so that you are also placed in the scientific world as one of the researchers. I wish every one of you all the best this day. May God bless you, and thank the department and congratulate the department. Thank you very much.
Thank you, Father. I now invite Reverend Father Principal to first day the gathering.
Dear Father Secretary, dear Chief Guest, Jnanamani and Arivalagan from IIT Roorkee and National NIT Trichy, and our HOD, our Vice Principal Rayapan, and our Dean, both are from our own department, and our researchers, Amal Raj and John Jeevahan and other professors and my dear students. It's a really pleasant morning. Even yesterday it was not like that, but this morning welcomes you all with slight drizzling, and the mood is wonderful. Really nice. The topic of this national seminar is expanding frontiers in chemistry. When I was having a talk with our chief guest, Jnanamani, he has done his research on நம்ம நட்டுவாக்களி அப்படின்னு நம்ம சொல்கிறோம் இல்லையா, நட்டுவாக்களியில் இருக்கக்கூடிய அந்த விஷத்தை எடுத்து அதை ஆய்வு பண்ணி how it is going to help medical field. Food chemistry and medical chemistry is a very, very famous and wanted more people, more researchers. நான் சின்ன வயசில் கையில் வந்து ஹாஸ்டலில் கொண்டு போய் விட்ட பொழுது எல்லாருக்குமே சிரங்கு இருக்கும் இல்லையா, எனக்கும் சிரங்கு வந்திருக்குது. ஓகே, ஹாஸ்டலில் படிக்கிறவங்க வீட்டில் உள்ளவங்களுக்குமே சரி தான், சிரங்கு இருக்கும். நம்ம ஊரில் குப்பமணி கீரை தெரியும், அதை பிடுங்கி கொஞ்சம் மஞ்சள் கொஞ்சம் உப்புக்கல் வச்சு கசக்கி என்னுடைய பாட்டி கையில் வந்து தேய்ச்சி விட்டால் பயங்கர எரிச்சல். ஒரு 2 நாளில் காணாமல் போயிடுச்சு. இந்த ஃப்ரான்டியர்ஸ் அப்படிங்கிறது எங்கே இருக்குது அப்படின்னா, நவ் வி ஆர் ஸ்பீக்கிங் அபவுட் இந்தியன் நாலேஜ் சிஸ்டம், அண்ட் தெர் ஆர் so many herbals available in our land. We are very fortunate. Tamil Nadu is very fortunate because we are in that equator area where we get multiple medicinal plants which is not available in other countries. We cannot find any plants in Kashmir, isn't it? We cannot, I have been there in Europe and other countries. You also would have heard, not many medical herbs, but their research is high and they are able to establish this medical chemistry. But since our research is weak, we are not able to contribute more, and we are not able to show that this Kupamani or any other Keelanelli, there are so many plants which are available which are going to help the whole human race. So we need more researchers. We need to expand our research areas. So that's expanding frontiers in chemistry. That's the only idea that I get. We have antivenom, but antivenom will equate. I too was bitten by a snake, so I was immediately taken to a government hospital. That antivenom injection was given to me, and I was normal. But even that little bit of the visham is going to help even HIV patients. He was sharing with me, even the HIV patients will get benefit from this சின்ன சிறு துளி விஷத்தில். நம்ம மெட்ராஸ் பக்கமாக போயிருந்தோம் அப்படின்னாக்க நம்மளெல்லாம் கூட்டிகிட்டு போவாங்க மகாபலிபுரத்தில் ஒரு பாம்பு பண்ணை இருக்குது. அந்த பாம்பு பண்ணைக்கு நம்ம விசிட் பண்ணோம் அப்படின்னாக்க அங்கே உள்ளுக்குள்ளே ஒருத்தர் உட்காந்துருப்பார். பயங்கரமான விஷ பாம்புகள் அதுக்குள்ளே இருக்கும். நம்மக்கிட்ட போன உடனே காட்டுவார், அதை அந்த விஷம் அப்படி எடுத்து காட்டிட்டு விஷத்தை அந்த பாம்பை அப்படியே படம் எடுக்கிறதெல்லாம் காட்டிட்டு அதை ஏதோ ஒன்று செய்வார். அதுலேருந்து லேசாக விஷம் கேட்கும். ஒரு துளி தான் கிடைக்கும். சார் வந்து சொல்கிறாரு, நம்ம நட்டுவாக்களியை பார்க்குறோம், அதை அடித்து கொன்னுடுறோம் இல்லையா, ஆனால் அந்த நட்டுவாக்களியை நீங்கள் வளர்த்து அதிலிருந்து விஷத்தை எடுத்து நீங்கள் எக்ஸ்போர்ட் பண்ணாக்க யூ ஆர் அ குரோர்பதி அப்படின்னு சொல்கிறார். குரோர்பதி, பல கோடிகள் நீங்கள் சம்பாதிக்க வேண்டிய ஒன்று. அதே மாதிரி தான் நம்மளுடைய கலைகள் அப்படின்னு நம்ம சொல்கிறோம். நிலத்தில் நம்ம வந்து விவசாயம் பண்ணுறோம். நமக்கு வந்து மிளகாயை விவசாயம் பண்ணுற அளவுக்கு நம்ம வந்து குப்பைமேனியை வந்து என்ன செய்கிறோம், அதெல்லாம் வந்து கலை அப்படின்னு சொல்லிட்டு களக்குள்ளியை அடித்து அழிச்சிடும். நீங்கள் ஒரு கெமிஸ்ட்ரி, இங்கே இருக்கக்கூடிய ஒரு கெமிஸ்ட்ரி நபர் அதை ஆய்வு செய்து இதில் உள்ள கெமிஸ்ட்ரி இவ்வளவு தான், கெமிக்கல்ஸ் இவ்வளவு இருக்குது, இதை இப்படி எக்ஸ்ட்ராக்ட் பண்ணலாம் அப்படின்னு சொல்லிட்டு ஒரு கம்பெனி நீங்கள் ஆரம்பிச்சிங்க அப்படின்னாக்க யூ ஆர் கோயிங் டு பி அ crorepati. இன்னமும் வந்து கை காலில் புண்ணுகள் வருது, சிரங்குகள் வருது, இன்னமும் வந்து நமக்கு மஞ்சக்காமாலை வருது. நமக்கு தெரிஞ்ச ஒரு சில மெடிசின்ஸ், திஸ் ஆர் ஆல் medicinal plants which are commonly used, but there is no chemically proved how it is going to help. So, my dear students, there are some good students which are available. Our Karmuhil, our second MSc student is trying to have degradable carry bag with Amal Raj and other researchers. He is working at. Our John Divagan also is helping that student. We are going for patenting. There are some students who are with that mind, and you are going to be in the research field. I wish that after BSc, you should not go into a teaching profession or BSc முடிக்கிறோம், ஒரு பிஎட்டை முடிக்கிறோம், ஒரு ஸ்கூலில் 10,000 ரூபா 15,000 ரூபாய்க்கு நம்ம வந்து சம்பாத்தியம் வாங்கிக்கிட்டு நம்ம வந்து செட்டில் ஆகணும். நோ. ஆர் நல்லா படித்து ஒரு டீச்சரை ப்ரொஃபஸர் ஆகி நான் வந்து ஒரு காலேஜில் ப்ரொஃபஸர் ஆகணும். நோ. I wish that you all must get that idea of research. You need to get into that research, and we have ample chances for that. I wish and pray that this kind of seminar and this kind of people from IITs will inspire our students to get involved in this research field. All through your life, you need not go to anywhere. You can be there in your research lab, and then you can continue your research, and you will be a big person. So I wish that should happen in our campus. I really appreciate the initiatives that is taken by our chemistry department professors. They are all our best professors. You all know. You will vouch my statement. So they are all very good professors. So please get involved and get interested in it, and then you also should become a researcher. I thank wholeheartedly the department, the initiatives which are taken by our head of the department and other professors. And my dear students, please get benefit out of it. I wish you all the best. Thank you very much.
Thank you, Father. To give us a glimpse of our institution and the spirit behind this national conference, we now invite attention to a short video presentation. This video reflects our journey, achievement, and academic vision. Kindly watch the video. I request.
We shall now proceed with the felicitation of our chief guest. I invite Dr. E. Jnanamani, Associate Professor, Department of Chemistry, IIT Roorkee, for felicitation. At this moment, we are delighted to honor our esteemed dignitaries whose presence and support have greatly enriched this conference. And I request Dr. E. Jnanamani to kindly come forward for the felicitation. May I request Reverend Father Principal to honor him with a shawl. May I request Reverend Father Secretary to present the memento to the chief guest.
Now I request Dr. C. Arivalagan to kindly come forward for the felicitation. May I request Dr. S. Rayapan to honor the chief guest with the shawl. I request Deva Prince sir to present a memento.
Let us express our appreciation with a warm round of applause.
To give up the glimpse of. It's now time for the most awaited moment of today's program. We are deeply honored by gracious presence of our chief guest. Dr. E. Nyanamani, Associate Professor, Department of Chemistry, IIT Roorkee, whose achievements and contribution has been a source of inspiration, to formally inaugurate this one-day national conference and to share his valuable thoughts. I great pleasure in inviting our esteemed chief guest, Dr. E. Nyanamani, to deliver the inaugural address. May I request Dr. E. Nyanamani to come forward and address the gathering. Conference proceedings stand as a valuable record of scholarly contribution and the academic deliberation. At this juncture, we move on to the release of conference proceeding of this one-day national conference. I respectfully invite Dr. E. Nyanamani, Associate Professor, Department of Chemistry, IIT Roorkee, to release the conference proceeding. May I request Reverend for the Secretary to receive the first copy of the proceedings. Let us acknowledge this moment with a warm round of applause. I also invite all the faculty members to come to the stage. We believe these proceedings will serve as a meaningful academic resource for researchers and scholars. Thank you, sir. Thank you, Father. A newsletter reflects the activities, achievements, and academic spirit of our institution. At this moment, we proceed with the release of conference newsletter, Chem Frontiers 24-25. The newsletter highlights the key academic and research achievements of Department of Chemistry during 2024-25, reflecting its commitment to excellence. Major highlights include of student qualifying IIT JAM and securing admission to NIT Calicut, Best Innovation Award, NPTEL Swayam certification with faculty mentorship, and significant faculty contribution through research, publication, and academic engagement. It also features the Silver Jubilee UCG sponsored National Conference, Expanding Frontiers in Chemistry, EFC 25, along with student field visit and internship at premium institutes such as ISER Thiruvananthapuram, CISR, Sikri, IIT Madras, and NIT Trichy, underscoring the department's strong research culture, industrial academia linkage, and holistic educational approach. May I request Reverend Father Secretary to release the newsletter. May also we hope this newsletter serves as a meaningful record of today's conference. Thank you, Father. To formally inaugurate this one-day national conference and share his valuable thoughts, I take great pleasure in inviting our esteemed chief guest, Dr. E. Nyanamani, to deliver the inaugural address. May I request Dr. E. Nyanamani to kindly come forward and address the gathering.
Okay, good morning one and all. So today actually once I entered the college, I saw that actually the college is very clean. I'm expecting the same thing will happen in the whole Madurai, and then it will expand further to Tamil Nadu and then all over India actually. It's one of the best thing I saw actually once I entered the college actually. Next actually, like I hope most of the students are from chemistry. Are they are different? Okay. So how many of you applied this time actually CSIR or GATE as a student? PG students? None. Actually, one of the important thing that when you are doing master degree, you must apply for CSIR actually. Must qualify. Anyway, you may see Professor Savida or other faculty members also, of course, they encourage you all. Please actually apply for the CSIR. That's one of the main thing in India actually what's happening. What about GATE? Any idea what's the expansion for GATE? This is the one of the things, where I did my master in Madurai Kamaraj University. Once we enter master degree, always actually first year ranking happens. I don't know nowadays it's happening or not, but in 2002, 2003, those time it happens. They ask actually what is the expansion of GATE. So please go and look. You will have idea actually. Also, everyone must apply for the GATE, CSIR as a student level. If you are not applying, of course, actually you cannot come up for the next level. As I think principal just before what he said actually, please don't look for like a kind of going for teaching position after your BSc or MSc, or similarly don't go for kind of TNPSC. Actually in India, in Tamil Nadu actually, majorly I'm seeing that students are after completing their bachelor degree, they apply for TNPSC. Anyone applied here TNPSC or anyone wrote exam? Okay, that's good. Actually, that's one of the thing I don't like actually, like students actually has to come in the higher stage actually. And stop looking in the lower level. Suppose it's the only necessary thing you want to do, then actually you can go for those kind of exams. But otherwise, if you are able to go for higher studies, please go for the higher studies. Even in India, actually, like women scientists, actually, always they were recommending everywhere. If you look actually any exams, women's actually given the preference. Even in the institutes, academic institutions, if you go for some student, women's candidate going for the faculty position, given the first preference. You may know actually, you may see your department also where in Arul Anandar college also, women faculty will be less now. But this has to change. We know that 12th grade, many students are qualifying I think first mark always actually in the 12th standard qualified by the women candidates. But in case of higher studies, it's very, very less actually. What's happening? This has to change. If you can go any other country other than India, women's actually equally they are participating everything. But in India, it's still less. Please actually everyone apply for higher studies, actually go for PhD. I think everyone knows PhD, correct? How many of you all are here? How many of you master students here? Why actually master students are sitting the last? Okay, so one of the things actually, please apply for the PhDs. There are several opportunities in India. Even government actually paying a lot of money for students. I hope that recently actually something called PMRF, Prime Minister Research Grant actually for the students, where they pay for PhD student as a stipend 80 to 90,000 rupees per month. If you go any job in India, as a BSc student or MSc student, you are not going to get. But Indian government is paying that actually for the students for studies, not for the job. So apply for those kind of fellowship. For that actually you have to just need to qualify the CSIR. If you qualify, if you enter in NITs or IITs, then of course you can go for to get the PMRF. Once you are the PMRF candidate, next actually you can go for higher education in abroad, and then you can come back. Even I also grown up in a small village, and then studied in a small college, Pasyabas College in Kanchipuram. Later I moved here to Madurai, where actually Madurai changed me a lot. Same thing actually, if you go for higher studies, you will change. But if you are thinking like, yeah, I have to go for after bachelor degree, some BEd, or actually some kind of teacher training course, and then I will just graduate from the teacher training and then go for schools. That's a really bad thing actually. It's not like a teacher training all actually gone actually. Now you have to think about in higher level. Whoever the teachers you are seeing all are graduated, doctors. They help you how to get the PhD. Once you got PhD, you can do whatever you want actually. That's your life. What actually the principal of the college is saying, where actually we also invent kind of scorpion venom. If you want the money, actually one can earn lot actually. But it depends actually which area you are choosing. After PhD you can decide actually, but don't decide your career after your BSc or MSc. That's a very important thing. I hope actually next time when I see this same college, or I will ask her also, every student applied, she will tell that every student applied for CSIR or GATE. So normally GATE application will come in August or September, something like that. Please ask actually your teachers. They will help you actually how to apply. And many times it's a free also, application fees is free also. It's not expensive. Or similarly CSIR also. If you are qualified CSIR, you are eligible to go for after MSc directly college teachers or college professors with CSIR qualification. That's also, like anyway, I hope some of them knows the NET exam. Anyone knows NET? Net qualification. Okay. Yeah, Tamil Nadu government also conducts some NET exam, but going for the CSIR is the best way actually, because you are actually centrally qualified, and then you can move not only in Tamil Nadu, anywhere actually. And that motivates you go for the higher level, higher like PhD, further postdoc, and then you can come back India and then serve for the country instead of going in the smaller kind of thing. That's what actually main thing I would like to say, and wish you all the best to all. One of the thing actually I like here, same thing we conduct in IIT. Sometimes students won't come much actually in early morning. I'm able to see several students are here. That's good here. Okay, all the best to all then. Okay, thank you then.
Thank you, sir, for your enlightening and inspiring inaugural. As we conclude the inaugural section, it is only fitting to express our heartfelt gratitude to all who have made this event possible. And now we invite Mr. S. Deva Prince, Assistant Professor, ASC, to deliver the word of thanks.
So very good morning. So on behalf of the Department of Chemistry and the organizing committee, it is my privilege to propose the vote of thanks. So we express our deep sense of gratitude to our chief guest, Dr. E. Janamani, Associate Professor of Chemistry, Indian Institute of Technology, Roorkee, for graciously accepting our invitation and for his profound and insightful inaugural address. His scholarly reflections inspire us to pursue Margis, the constant striving for excellence while placing scientific knowledge at the service of the society. We gratefully acknowledge our respected management for their leadership rooted in vision and discernment. We extend our sincere thanks to Reverend Father Rector, Secretary, for their gracious presence, encouragement, and unwavering commitment in nurturing the academic growth and research initiatives aligned with Jesuit ideals. Our heartfelt gratitude is due to Reverend Father Anbar, our beloved principal, for his inspiring leadership, constant guidance, and commitment to cura personalis, care for the holistic development of every individual staff and students, and by emphasizing intellectual, emotional, moral, and spiritual values in all possible ways, which continues to strengthen the academic and other values for an institution, which adds values to our institution. I place on record our sincere appreciation to Dr. N. Savitha Devi, the head of the Department of Chemistry and the convener of EFC 26, Dr. A. John J. Vahan, organizing secretary, and the whole organizing committee, the faculty, and the student volunteers for their generous contribution of time and effort, exemplifying teamwork, commitment, careful planning, and tireless efforts in organizing this conference in a spirit of collaboration and service. So it is my pleasurable duty to thank our Dr. Arul Anandar sir for coming forward for this inauguration. Because of the time factor, he is unable to get a session to deliver the address for you. So thank you, sir. So it is my prime duty to thank the resource persons of this academic conference, Dr. Sivapriya madam, and other resource persons, Dr. Karumathur sir from Vivekananda College, and other faculty from other institutions, the student friends from other institutions, and also our own students and faculty for this for your tremendous generosity service towards this conference. Special thanks to the students who sang the prayer song, setting the tone to begin the EFC 26 in a nice manner. So finally, I thank all the one and all who have been the part and parcel of this program, and I ask you to I pledge you all that you will make use of this conference. May the deliberations of this conference lead us to deeper understanding, responsible innovation, and meaningful service to the society and contribution in a very good manner. So thank you all once again. Thank you.
Thank you, sir, for your kind words of appreciation.
To give us a glimpse of our institution and the spirit behind this national conference, we now invite your attention to a short video presentation. This video reflects our journey, achievements, and academic vision. Kindly watch the video. Thank you for this fabulous video presentation. We now move on to the technical session 1 of this EFC 26. This session focuses on and will feature insightful research presentation. I take this opportunity to welcome Dr. E. Nyanamani, Associate Professor, Department of Chemistry, IIT Roorkee, to present the topic ultra-fast formation of carbon-carbon, carbon-nitrogen, and carbon-oxygen water microdroplets. We also extend a warm welcome to all the presenters and the participants of this session. I request the session chair, Dr. N. Savita Devi, Head and Associate Professor, Department of Chemistry in AAC, to kindly take over the proceedings of the technical session 1.
A very good morning. I'm really very happy to chair this session. Dr. Nyanamani is Associate Professor in IIT Roorkee. He did his UG in Pachayappa's College, Kanchipuram, and MSc in Madurai Kamaraj University. I got the opportunity to interact with him. He was a shrewd learner at that time, even at that time I remember, and still he's like that only till now. And he's completed his research PhD in Pondicherry University under the guidance of Professor Ramanathan. And then he did his postdoctoral studies with Professor Cheng at ICCAS, and later with Professor Trost at Stanford University. Fellow. At Stanford, he also collaborated with Professor Jair in microdroplet chemistry, a recipient of Fulbright Award, Developing Country Award for International Researchers, and Best Mexico Patent Innovator Award. He is an associate editor of Current Indian Science. His research spans asymmetric catalysis, total catalysis, and microdroplet chemistry. He has a wide and vast interest in research, and he has published in international journals to his credit and to the credit of the institute. So may I now invite Dr. Nyanamani to deliver a lecture on the topic ultra-fast formation of CN, CO, CS bonds in water droplets. Thank you.
Thank you, ma'am. With that, I now invite Dr. E. Nyanamani to take the stage and share his expertise with us.
Thank you. Yeah. I think it's direct. Okay, thank you, Professor Savita, for your kind words. Okay, everyone able to hear? Yeah. Okay, good morning to all. Today actually I am going to talk about ultra-fast formation of carbon-carbon or various carbon X bonds actually by using microdroplet chemistry. Most of the student knows organic chemistry, correct? So how we do the organic reactions? Like in the lab. Anyone had worked in the laboratory? I think you were in 12th class also use the test tubes, do the carry out the reactions or some round bottom flask. That's actually old tradition way actually, that's the way we work. But here actually I have given the title which is micro droplets. So where actually you can apply the voltage and then in a micron size one can convert the products, reactions. Like for example pharmaceuticals. When they want pharmaceutical, they don't need lot of quantities. They may need microgram quantity for testing the biological activities at the beginning. Suppose actually if you are relying on organic chemists, it takes enormous time. I hope during COVID everyone had issues. COVID, yeah. Yeah. So during COVID time also we have seen there are new medicines came, new vaccines came, all actually very short invention, but all actually they use kind of high throughput chemistry. What is that high throughput? Those things I will discuss in the next few slides actually. Everyone knows that, okay, I think, okay. Yeah, move. Okay, is that fine? Everyone knows the water droplets, correct? Even today also while raining also you may have seen that droplets on the leaf. Suppose actually if you apply with pressure, if you apply with the pressure, we get micron-sized water drops. With micron-sized water drops, one can carry out the reactions. If you just spray, and then one can carry out the reaction actually. That's what actually today I am going to show. So in this place, In this place, one can carry out the various organic reactions actually. This is the highly energetic area where actually the water is in the micron size. Due to the coulombic interaction, one can carry out the organic reactions. That's what actually today going to discuss, not like a traditional organic synthesis actually, which is actually recent field, which is emerging area, which has been invented in 2012, but 2019 onwards only actually it's emerging lot. Before 2019, one or two papers came. But nowadays actually one can carry out the reactions in water actually by spraying actually. Anyone actually have idea what is the use of mass spec instrument? Students? Like when we are looking the organic compound, we write the molecular formula or molecular weights. Where they come from? By using the mass spec, actually one can get that. So by using the mass spec technique, one can also carry out the reactions. I hope master students are studied mass spectrum. Mass spectrum, you guys have mass spectroscopy. So if you see the mass spectroscopy, actually there are several fragmentation peaks will be there. The molecular ion fragment, and then we will get the daughter ion and then several fragmentations. Those fragmentations are highly unstable. If you isolate those unstable fragments, one can carry out the new reactions, which is not possible actually in the traditional method actually. That's what actually going to show today actually. Like traditionally actually mass spec instrument will be useful for carrying out the measuring the molecular mass or identifying the molecular formula. But what we do actually by stabilizing the mass spec intermediates, actually the intermediates of mass spectrum, and then we carry out the various organic reactions actually inside the mass spectrum actually. Like where actually the person actually who is standing here is starting the reaction in front of the mass spectrum. Mass spectrum tool actually normally useful for measuring the mass or actually identifying the molecular formula. But what actually we do, we keep the organic reactants and then we measure, directly do the reactions and then measure the structure, actually or identify the molecular formula. So traditionally we knew that this is one of the glycine rearrangement. So traditionally one can do the reaction in a flask. That's the way traditional way. But the recent field, one can apply the mass spec area, just applying the very high pressure. Yeah, don't disturb that. Yeah. If you apply very high pressure, one can carry out the same glycine rearrangement by taking the starting materials in the reaction flask or the flask containing the with the pressure and then just to spray them, one can carry out the same organic reactions. The major advantage here, once actually we collected reaction, no more reaction, only actually reaction occur during the spray. But in a case of traditional organic reaction, even the product formed, which goes for several byproducts, several further, this can be arrested. That's one of the major challenge we have in organic chemistry. That can be arrested by using this technique actually. In this area, there are two pioneers in the world who are actually invented. We have Professor Zair from Stanford University, who is one of my boss also. Actually, I worked with him. And Professor Cooks, who is from Purdue University. So those two are popular universities in USA actually. So where actually if you look this is the mass spec principle. Taking the sample in a syringe, spraying into the mass spectrum, we get the molecular formula or molecular mass here actually by the detector. But the same method, if you take the starting materials A plus B and then spray, and then one can carry out the reactions here. That's what the new, yeah, I think, yeah, just a moment. for the organic reactions. Actually, this is the setup where we design for the organic reactions, which are very new. Even at a small college or small schools can sponsor this. Okay. So if you take the cup of water, can you imagine from the water what you can convert? Anyone can guess if you are taking the water in the cup or in a beaker. At the maximum we heat and then we drink. Anything else actually can we do with water? Only water. So what is the molecular formula for water? H2O. Can you think now what we can do with water then? The water or ionize the water. H plus and OH minus. Yes. So H plus OH minus, again actually they can, if the OH minus lose the one electron, what happens? If the OH minus lose the electron, it makes radical, hydroxyl radical. I hope everyone knows that radicals are highly unstable. They tend to go for further reactions or they will die actually. So if you take the cup of water and then if you spray with this setup, one can directly convert into the disinfectant. I think during COVID, everyone used the hand sanitizer. If you look at ingredients, what is the hydrogen peroxide? Hydrogen peroxide, one of the popular disinfectant actually. First actually the water forms H plus and OH minus, and OH minus lost one electron and then formation of hydroxyl radical. This hydroxyl radical is very unstable, which recombine and then formation of hydrogen peroxide. If you look industries, how they make, it's very, very difficult, very expensive route to make hydrogen peroxide. But by using this simple setup, one can convert this cup of water directly into the hydrogen peroxide. Where actually it can be used, you can take directly water and then spray actually where you want actually disinfect, sir, where you want to make that clean. You directly spray the water with very high pressure, directly formation. If you see, if you go to that lakes, have you seen anywhere in the lake area nearest to the lake? Kind of, not in the lake, falls. Like kind of fish or anything. Anyone? I think maybe Kutralam Lake falls, many students went hopefully. Did you see actually in the lake, nearest lake, any fish actually going? Did you check? Anyone found that? You may not. You may always think that, yeah, it's actually fish is not available because due to the pressure, it's nothing like that. Due to the very high pressure, when the falls water falling down, water breaks, and then formation of hydroxyl anion, OH minus. That OH minus lost the electron due to the static interaction. Due to the static, it loses one more electron. In nature, actually, it happens. You may see actually several places, ghosts, like people say that actually night time, actually we see the fire, or it's always actually happening due to the formation of radical intermediates. I will show something about that also in future slide about with this actually. What's happening, actually we always have the myth, ghost actually there in the world. But maybe recent science paper actually of course published by him, you can look actually where actually ghosts are not actually it comes from the water actually. So during winter time, if you take some sweater, if you pull out, you may see some kind of spark comes. Anyone identified that? I think you have to go further colder climate, then only you can identify. Just if you pull out from your dress, you will see spark comes. Those spark only actually, always we have myth actually, yeah, goes there, actually in the nature it happens. But same thing happens in the formation of radicals from the water actually. So this is a simple setup where hydrogen water actually we are spraying actually. When we spray only the water without pressure, there is no hydrogen peroxide formation. Suppose if you apply with very high pressure, you can see that blue color formation actually it's not visible much here, but the blue color will be there, which clearly tells the hydrogen peroxide formation from the water actually. Otherwise, industrial route of hydrogen peroxide formation is very expensive. This is actually simplest method. So even actually hand sanitizers actually, that's what I said, it's available actually. So I said actually water one can convert it into hydrogen peroxide. Not only the hydrogen peroxide, one can also carry out the reaction. Here I have given one of the gentlemen name actually Professor Sharpless. Have you had anybody knows who is Sharpless? Sharpless epoxidation. Any other? Who won Nobel Prize 2 times in chemistry? He is also from Stanford University, of course. In their life, in a chemistry, actually 2 times in 2001 as well as 2021, 2 times, one for chiral chemistry actually. Hydrogenation chemistry as well as 2021 for asymmetric organic catalysis. He won actually with click along with click chemistry, he won the Nobel Prize. So during 2005, they made that actually this is a cycloaddition reaction, 2 plus 2, 2 plus 2 cycloaddition reaction, where the product formed in toluene, that was the first invention by Sharpless in 2005, 24 hours with a 74% yield obtained. Later, in the Nature actually they have published in the same year, just doing the reaction in water, the rate of the reaction several fold increased from 24 hours to 10 minutes actually, they reduced to time. So it means that reaction is accelerated. Very recently actually at Stanford, we made that reaction in microsecond, 100% conversion in microsecond. You can imagine from 2005 to 2020 how actually the science evolving. Now actually one can do that in a fraction. Even actually just mix, you will see the product. That's what actually, if you look at the reaction rate, it's a 10 to the power 6 times than whatever they've done in 10 minutes in that paper actually. So that's actually advantage of the microdroplet chemistry. Of course, actually it is very new. Soon actually it will come into the books. Then actually everyone knows actually what's going on in a microdroplet. Not only actually like organic reaction. Here I showed another one interesting example where actually the gold nanoparticle. Anyone have idea what is the use of nanoparticles? Nowadays everywhere, I think hopefully everyone knows what's the advantages of nanoparticle. Nanoparticle has been synthesized in a bulk chemistry in a flask, longer time, but the same nanoparticle has been synthesized within microseconds, 10 to the power of 5 times faster rate. So just need to take the sample, starting material in the syringe, and then just apply the pressure, and then one can directly get the nanoparticle from the solution in a very high speed, as well as actually the particle size can be changed. So when you go for this smaller and smaller nanoparticle size, their property will be huge. Please read actually after going home actually what is the importance of nanoparticle, you will have idea actually. So here actually I'm going forward to the organic chemistry. In organic chemistry, CC bond, carbon-carbon bond formation is very, very important. This is one of the basic example we have chosen. It's a very, very old example, but how actually we can do it in a modern method or microdroplet method in a faster route, faster way. If you look actually this phenyl acetic acid, this is a phenyl acetic acid, it's amide part actually. How one can make from amide from acid, can you comment? So one starting material is acid, your product is amide. What is the another starting material? Amide. I think I'm expecting from students, not from teacher. amide. Amide how to make? Acid plus amine. One can get the amide. So this is actually amide form. What about ester then? Ester, how to make? All are 12th class chemistry. I am not asking bachelor degree also. Acid plus alcohol in presence of base, or acid, both way possible actually. Okay, anyway, this is actually phenylacetic acid, which is actually protected form of amide. If you look actually this phenylacetic acid, there are several drug molecule, commercially available drug molecule as that phenylacetic acid core. And if you look in the industries, how they make the route, make it in a longer route. But what we have done, we have taken a toluene and carbon dioxide from the CO2 gas, spray with the CO2 pressure, and then we get directly phenylacetic acid. You guys can check actually how routinely they make in the lab. This is the industrial method, still actually how industries make the phenylacetic acid. First, they make the chlorination by treating with chlorine in photolite, further treating with sodium cyanide, then of course SN2 displacement, then actually we get the cyanide addition, followed by hydrolysis, one can get the salt, and then further actually the neutralization, one can get the acid. This is the route actually, industries rely on this route to make phenylacetic acid, to make this all the bioactive compound, whatever I showed, all this actually penicillin G, antibiotics, there are several antibiotics actually contain the phenylacetic acid core, but industries always depend on this route. What is the challenge in this route? Need to use the photolites, chlorine gas, it's a dangerous, it's not easy to use, as well as required to use the sodium cyanide. I hope everyone knows sodium cyanide or potassium cyanide. Health risk, correct? It's highly dangerous. But industry is still actually relying to use the sodium cyanide, convert this. What actually we have done direct formation of toluene to the phenylacetic acid in a single step by using the carbon dioxide. So this actually reduces the CO2 level in a world, as well as actually we don't need to use any other reagents, whatever the reagents they used. Only CO2 gas and then water actually. Take the water and then toluene, shake well, spray them, you get the product. It's a simpler method. One can convert the toluene. If you look the mechanism, what happens? Obviously, whenever the new area comes, always lot of challenge will be there. We need to prove the mechanism. Otherwise, actually, it's very, very difficult. When we are saying actually, there are several industries working on this area, and then we are saying, no, actually, whatever the industries are doing, it's unnecessary. We can do it in shorter route. Then actually we'll have challenge. Then of course actually we make actually all the intermediates we identify by using the mass spec instrument. Like first formation of hydroxyl anion from the water, and then loss of one electron, formation of hydroxyl radical. This radical is highly energetic. Now the radical going to deprotonate, cleave the bond, formation of benzyl radical, and then of course H2 is the another byproduct. Then this benzyl radical is highly unstable, which lose one more electron. In this case actually it abstract one more electron, formation of anion, benzyl anion. Now actually this anion is sufficient to add to the carbon dioxide, then we get the phenylacetic acid. All the intermediates actually whatever I showed, everything we identified, we proved. So then only it has been accepted in this JACS paper in 2023. It was a long journey. We struggled to, yeah. Sorry for that. Okay, I think, yeah. So whatever you are reading in a book, textbooks, we are always saying that anion formation or, oh please actually, நீங்க touch பண்ணாம. So in textbooks, we may see that actually carbocation, carbanion. Yeah, I think you can remove your hand, it works. If you are not disturbing, it will not.
Participants, please remain silent.
Okay. Okay, sorry guys. Actually. So in a textbooks, actually, you will see that carbocation, carbanion, carbon radical. How, from where they get any idea? How we write actually in a textbook? Any idea? In the olden days, actually, without proof, actually, but nowadays there are tools. One can exactly, is it radical? Is that actually anion? Is that a carbocation? One can easily identify it. There are methods by using the mass pick or for the radicals, actually, one can use the trapping agent. I will show what is that. One can get that exact idea of what's going on. That's what actually now science have evolved, actually. Next, actually, I showed here actually carbon-nitrogen bond formation reactions. What is this core actually? If you have actually benzene ring with CH2NH2, what is the name of the compound? CH2, benzene CH2NH2. Phenyl CH2NH2. Benzylamine, correct? So, benzylamine core actually present in several drug molecules actually, and traditionally they require to use the metal reagents to carry out the reaction. If you look, actually there are commercial drug molecules where actually the, okay, some of the, I think you can switch up this. There are several drug molecules which contains the benzylamine core. And you can look actually this has so benzylamine, here actually benzylamine. There are several molecules as the benzylamine core. Always actually we industries need to make those drug molecule by using various method. One can first do the photolytic condition, convert from toluene to the benzyl chloride, and then followed by amination. One can do that, benzylamine. It's a simpler way actually, that's what actually do that industries. Or first oxidation with very high temperature, 400 degrees Celsius, and then hydrogenation with very high pressure. Another actually, suppose if you oxidize the under strong oxidizing condition, If you oxidize the toluene, one can oxidize. What is the product you will get if you oxidize the toluene? Anyway, already I have showed the product here. Benzoic acid, and of course in some time you can expect actually benzaldehyde actually as the intermediate, which will go for further reduction with amination. One can get benzylamine. These are the methods actually currently available for carrying out these type of reaction to form the benzylamine from the toluene. But all the methods actually suffering with certain problems. Certain cases required actually photolight or very high pressure or temperature 400 degrees Celsius is very, very difficult. It's not a natural condition one can do in laboratories actually. But of course, highly equipped lab one can do that. But it's not something convenient. Or required to use 5 bar, very high pressure actually. It's challenging for the industries. But what happened actually due to that, if you use multiple methods, industry is going to produce lot of byproducts. Those byproducts are going to harm the pollution. They are going to pollute the air actually. That's what even we are seeing today actually, how actually India, like Delhi area, how they are polluted actually. If you look actually due to the pollution, this is a 2019 study, but 2024 somehow I am unable to get update one. 2019 in the world actually, 2.33 million people are dying due to the only pollution. That's a majorly only from the India. Of course, next level China. Now China is reducing lot actually. But we are the highest. Air pollution in the world, which country will be the first? Any idea? Air pollution. Yeah, look the study actually. This is Delhi actually, India. We are first in the pollution, air pollution in the world actually. Still, it shows in the, see what happened actually, many person in abroad or actually foreign, they feel actually, yeah, India is not safe. So what we have to do? We have to make clean, and if you are even actually as a chemist, what is the involvement we can do? We can reduce the pollutions from the industries actually. That's why actually many places in industries, they produce harmful gases, and then those harmful gases, if they use actually cyanide, sodium cyanide, when they neutralize, what is the byproduct they get? Any idea? When they do the sodium cyanide reaction for benzyl chloride to benzyl cyanide, they use sodium cyanide or potassium cyanide, poisonous reagent. For neutralizing, they have to use HCl. When the HCl added to stop the reaction, when they are adding little excess of HCl, it's going to produce HCN. HCN is a gas. What happens in industries, they produce HCN gas, night time they just open it. So nearest area, people die. Nobody knows how they died. But this all happens due to the industry. So, of course, as a chemist, we have to solve those problems. Water polluted,